section 1, chapter 1, lesson 2. So now we're going factorial notation and permutations, kind of talk about repetitions a little bit, and go through different things we're going to see with that. So let's get to it. First off, let's talk about what a factorial is. So, and consider how many ways there are arranging 6 different books side by side on a shelf. Using fundamental counter principle, we calculate the product to be 6 times 5 times 4 times 3 times 2 times 1. And so a way you can think about that with the fundamental counting principle is you have 6 spaces for books. And then how many books do you have? 6. And then if you take 1, now you have 5, 4, 3, 2, 1. So essentially, if you're mixing up 6 books in 6 spaces, it's 6 times 5 times 4, 3, 2, 1. That is, a factorial. 6 times 5 times 4 times 3 times 2 times 1 is 6 factorial. Okay? So all a factorial means is multiplying down from that number to 1. Okay? That's all factorial means. It's in your calculator. Okay? If you go to math, I think it's in the probability section, number 4. Okay? If you hit math, probability number 4, it's in that section there. Is that right? Yeah. Okay. So 4 factorial without your calculator, but if you have it, you can try if you want. But that means 4 times 3 times 2 times 1, 12, 24. 4 factorial is equivalent to 24. Okay. 3 factorial, 3 times 2 times 1 times 2 times 1. That's 6 times 2, really, which is 12. Okay, then it says, notice that 6 factorial can be written a variety of ways, and we use this to help us solve algebra later. Okay, we get to some binomial theorem and some solving stuff later. But 6 factorial can be all the way down, or you can write it all the way down to 2 factorial, all the way down to 3 factorial, all the way down to 4 factorial, etc. So you kind of write it shorthand in ways that can help you later for algebra. So there's understanding that I can stop anywhere I want while I put a factorial if I stop early. Okay, so that's just kind of the idea with that. Okay, and so this is kind of why. This is kind of an example to show how it can help you a little bit. So if I want to know what 6 factorial times 4 factorial is, or divided by 4 factorial, I can walk the 6 down to the 4 factorial, and then these are equivalents, so they cancel. Okay, you're going to use that. I know that's really basic. You're like, why don't I just calculate it? Sure, you can calculate this, not a problem. But we're going to have variables later where you're going to want to cancel and help you solve, okay? So this kind of idea is something you're not going to want to just overlook. So it's 6 times 5 is 30. If you calculate that in your calculator, if you actually put 6 factorial divided by 4 factorial, you will get 30 as well. Okay, do 5 factorial in 4 different ways. Okay, so 5 times 4 factorial, 5 times 4 times 3 factorial, 5 times 4 times 3 times 2 factorial, 5 times 4 times 3 times 1. So there's all different ways you can write 5 factorial. Okay, any questions about factorial so far? I think it's in math, stat, number 4, I believe. Prob, sorry, you're right, thank you. Prob, number 4. Okay, so complete the following. 12 factorial is equal to 12 times 11 factorial. 8 factorial is equal to 8 times 7 times 6 factorial. Okay, and so now we're just kind of thinking about how these would come about. So for example, on this one, how would you have 6 times 5 times 4 left? Well, that means you would have a 6 factorial over a 3 factorial. The 3 would cancel. Right? 6 and 5 times 4 times 3 factorial, and the 3 factorials would cancel. So that's how you get the 6 times 5 times 4. Okay, conversely here, 15 to 12. That means you have a 15 factorial over 11 factorial. So the 11 would take off the other 11. Okay. Let's go and look at these bottom 2 here. So 10 factorial over 7 factorial. So remember, that means we're going to walk the 10 down and have it like this, and now you can cancel it. Gone. So it's really 10 times 9 times 8, which would be 720. Now, the next one has 2 factorials. Don't let that mess you up, but I usually would take the biggest one into account first. So what I mean by that is I'm going to handle a 5. So I'm going to go 8 times 7 times 6 times 5 factorial. And so I'm going to cancel the 5 factorials. Now, with that, I'm not going to be able to cancel 3 factorial, but 3 factorial is 3 times 2 times 1, which is 6. So this is 6, so I can cancel that off. 3 factorial and cancel the 6, because that's what it's equal to. So just 8 times 7 for 56. And yeah, sorry, I said this was 720. Okay. Any questions on that? Okay. All right. Let's just keep on trucking. Let's go here, next one. All right, so factorial notation. So this is what I was talking about with the variables. So how you can write this with variables is that if you don't have a number, we know that if you have n factorial, the pattern is n times n minus 1, which is the next number down, n minus 2, the next number down, n minus 3. Okay, so that's how you'd write that if you had a variable in terms of walking it down per number. Okay, so the number, so like 8 factorial will be 8, 8 minus 1, 8 minus 2, 8 minus 3, and it keeps getting that next number down. Okay, I'll refer to that as walking down. We solve here later. Okay, any questions about that? So n minus 1 just means the next number down. Okay, all right, so then let's look at some context here. So complete the following. So n factorial is equivalent to n times n minus 1 factorial. Okay, now they put a plus there, so it's a little bit different because it's not an n this time. So what would that be? So n plus 2 factorial, if I want to walk it down to an n, how does that work? Right. Whoops. 2, 1, and then minus 1 gets you none, so then there it is. So n plus 2, n minus 1. So I know it looks weird. It is coming down 1, though. It was a 2, a 1, a none. Okay. I will say that's something they could do in the diploma because you get pretty comfortable with the minus ones, but the plus ones you forget you're coming from the other side of the n. All right. So n minus 4, n minus 5, n minus 6. So it is minusing 1, so that means this is n minus 4 factorial, because that's the first piece. And this is what I'm talking about here, being able to simplify with the variables. Okay. So I'll do the first one, then I'll pause the video. I want you guys to try the second two and see how you do. But the first one, so how I'm going to do is, right, what you look at first when you're doing these is you want to figure out which one's the bigger number. Is n or n plus 2 bigger? N plus 2, right? It's 2 above n. So this is the one I'm going to refer to as walk down. So we're going to do just like this here. Why? Because look, if I use this, what's here? N factorial, so I get that to cancel. Okay? So I'm actually going to steal this right here from my notes. So I'm going to go n plus 2 on the top. I'm going to go n plus 1. I'm going to go n factorial over n factorial, cancel. So n plus 2, n plus 1 is the equivalent. Okay? No, like not right now, no. If you were, if sometimes either they'll tell you like this is equal to 4, then you will FOIL and solve, but right now we're staying right here. Okay, all right, I'm going to pause the video. You guys go ahead and try the second two, see how you do. I'll be around for questions. Okay, so part B, the bottom's bigger this time because n minus 1, n minus 2, so the bottom's a bigger number, so I'm going to walk that down to like that. And so those cancel. So you're just going to get 1 over n minus 1 for B. Okay, for C, we're going to walk it down 2 times. It's going to give me n times n minus 1 times n minus 2 factorial. And then I can eliminate the entire bottom there. And it's simply n minus 2 factorial for C is where you'd be left. Okay, any questions on either of those? This one? Well, because I saw that as I walked this n down, because these don't have factorials, right? And so as I walk this n down, I see that I get the two things that are on the bottom, so that's my leftover. Well, you have to keep going because you can't. Your factorial can't just be gone because this thing continues and this doesn't. Does that make sense? So the factorial causes you to have to finish the factorial because we don't know what the number is. Good question, though. Okay. And then to your question, if this had a factorial right here, then you could cancel it, but it wouldn't be 0, it would be 1. Okay, when you cancel, it's 1, not 0. Okay. Good. Okay. So look at this guy here. So now this is what we're talking about. Now we have something equal to. So now we're not just leaving it. We're going to try to finish it. Okay, figure out what n is. Okay. There was one on the diploma similar to this just last fall here for the written section. So we walk this down. So this is the bigger number because n minus 2. So I'm going to go n minus 1, n minus 2 factorial on top. Now I have n minus 2 factorial on bottom. Those cancel. So I'm left with this like that. This is where you should feel a little bit comfortable. I know it looks weird because you're not used to doing this, but now you're solving. This is going to be a quadratic. So you're going to be solving by factoring here. This comes back to your math 20 and your math 10 skills. So we're going to go distribute n squared minus n. I'm going to minus the 42 over. And now we're solving by factoring here. We're solving by factoring here. Okay. So if I solve by factoring, 42's factors are n minus 7, n plus 6 that are 1 apart. And so your answers are 7 and negative 6. Negative 6 we reject because factorials have to be positive numbers. Factorials cannot be negative. They have to be whole numbers. Okay, so whole numbers means it can be anything above 0 and above that's whole. Can't have decimal factorials either. Okay, so factorial has to be 0, 1, 2, 3, 4, 5, etc. Okay, so negative 6 is rejected, so 7 is the solution. Okay, anything else? Okay, all right. Okay, let's go through some more here. So factorial notation on a calculator. So again, I already showed you kind of where to go. Many calculators have the factorial key, which can be simplified calculations. So use the factorial key to figure out those if you want to practice again. So math, probability, number 4. Okay, just calculate 6 factorial, 9 factorial if you want to practice. If you don't need to, it's fine. But we get 720. And the 9 factorial is a little bigger number, 362, 880. Okay, so there's your calculations. So the one thing I'd say to simplify the 10 factorial over 7 factorial, 3 factorial, if you do put this in your calculator, it's very important that you have a bracket at the bottom, or else it'll calculate it incorrectly on your calculator. If you just put in 10 divided by 7 factorial, 3 factorial, it'll multiply the 3 and not divide it. So make sure if you have a product on the bottom of a denominator, you bracket it. Okay? So that's what's happening. You make sure you do here. Okay? So if you did that in this case, you get 120 for these. So these are all 3 different ways of calculating it. But the biggest thing is just have brackets on the bottom, like I said, for that product. Okay, and again, if you calculate these two in your calculator, 43 over 40, we should know that's just going to be what? 43 times 42 times 41, right? If you want to kind of simplify it, you still can put that in your calculator as well. You're going to get 74,046. Okay, there's the one to practice with the brackets. If you want to practice, I'll give you a second here. I'll pause. So you should get, if you're trying it there, you should get 66,045. Okay, if you calculate that. All right, so a couple things. We just kind of did, the first part of this chapter is the fundamental counter principle and factorials. Those fundamental counter principle is very like putting out dashes, your problem, like what's your number of outcomes, stuff like that. Permutations can be done in fundamental counter principle sometimes, but the biggest thing that you have to focus on for this chapter is what's the difference between permutation and difference between combination. So right here, this is kind of the big idea, is that a permutation is the order of the arrangement matters. So the order is important. Okay, so I'm going to just give you a quick example now. This is going to be something you're going to have to continually kind of work on because it's a very hard concept. If I said, you know, I wanted to pick 4 of you to be president, vice president, secretary, and whatever, treasurer, okay, that would be a permutation example because I'm selecting 4 of you for specific jobs. So the order which I select you is important. If I select 4 of you, Langley may be the president, but he might be the treasurer. Okay, so the order matters. Now, the flip side, a combination example, is if I said, I want to select 4 of you to come with me on a field trip. So the order does not matter there because it doesn't matter who I pick, you're coming. Does that make sense? So there's specific jobs or specific orders, that's your permutation. If I'm just taking groups of people in the order which I take those people, that's a combination. Combinations later. Okay, lessons we're focused on permutation today. Does that kind of make sense, a quick little example between the two? Okay, if not, like we'll keep working on it, so you don't have to learn everything the first time. But internet sites access codes consists of 3 digits. Knowing the 3 digits is not enough to access a site. The digits have to be entered in the correct order. The order of the arrangement is important. John cannot remember the access code except it contains a 3, 5, 7 for digits. List all arrangements of these 3 digits that John could use to determine the access code. So we're going to kind of overdo it here. We're going to put all possible combinations of 3, 5, and 7. So you have 3, 5, 7, 3, 7, 5. You have 5, 7, 3, 5, 3, 7. Whoops. 5, 5, 3, 7. Sorry. And then 7, 3, 5, and 7, 5, 3. Okay. So there's 6 numbers possible if you know that's the digits. Let me erase that. It's bad. 5, 3, 7. Okay. 753. So there's 6 possible arrangements to consider, and only one of them will access a site. This type of arrangement where the order is important is called a permutation. So what that means is these are all the same digit, right? So 357 for a 3-digit code, that would be saying that's 1 would be a combination if the order of them didn't matter. So if the order didn't matter those digits, it'd be a combination. Okay, but the order does matter, so this is different ways we can order them. That's 6 different ways to order 3, 5, 7. Okay, so that's the difference. So permutation is arrangement of a set of elements in which the order of the elements is important. And they're going to say that quite a bit. All right, so let's keep looking at some stuff here. List all the arrangement of the letter cat. So all the ways you can arrange cat. So you have CAT, you have CTA, you have ACT, AT, whoops, we have ATC, and then we have TAC and TCA. Okay, so again, it's 6. There's 6 different ways to order the letters of cat. Okay, this is write the number of permutations in factorial notation. So how could you represent that in factorial notation? What's that? 3 factorial, correct. 3 letters that you're rearranging, right? So really, cat comes from 3 letters. What I'm saying, this permutations can be applied to fundamental counting principle because there's 3 letters to choose, there's 2 letters to choose, there's 1 letter to choose. That's why we keep getting 6 for the 2 things we just did. Okay, both things we did was 3 digits and 3 letters. We got 3 factorial, we got 6 for both of them. Okay. So number of permutations n different elements taking at a time is n factorial. So that just means we have 3 letters, we're taking all 3. The ways to make that combination, or I should say combination, to make that permutation of ways is going to be 3 factorial. Okay, so let's look at these before we get into repetitions. So Regina, 1, 2, 3, 4, 5, 6. 6 letters, they're all different. Okay, that's important. So how many ways can we shuffle that word then? Yeah, it's simply 6 factorial. 6 factorial. That's how many different combinations. So we didn't list these ones, obviously, because why? Well, there's 720 of them, so. Okay, well, I was going to list all those for you this time. Okay. Okay, so Kelowna, we're looking at 7, right? So we're on 7 factorial. And that's 5,040 ways to arrange Kelowna. Okay. Any questions so far? And I'll just be like frank with you, this is probably the most confusing chapter. That's why we're starting with it, so you guys see it the longest. Okay, this is probably the most confusing chapter. When you're reading the stuff, it's going to be a lot of verbiage, a lot of word problems, okay? So that's why we're starting with it. Typically, the lowest on the diploma is this section. So, use fundamental counter principle to determine how many 3-letter arrangements can be made from the letters of graphite. So graphite, are all the letters different? Yeah, so it wants 3-letter arrangements. That means we just have 3, right? So then what does that mean? What are we doing? 7, 6, and 5. So that's all you have to do. Stop there. Is it 7? Is it 8? Oh, my bad. 8. There's 8 letters. Yeah, forgot the I. 8, 7, 6. But you got the idea. We just count down 3 spots from the total. Okay, so that's 336. And so what you're doing is, that's the fundamental counting principle way of doing it. The permutation, so you can do permutation in your calculator. In this situation, it would be 8 permutation 3. So there's 8 letters to choose from. We want 3 of them. So that's in your calculator as well. Okay, and the probability, it should be number 2 or 3? 2? Yep, number 2. But you have to put the number first. So you put 8 NPR 3 in your calculator. So 8 first, then you do the math probability, number 2, the P, and then 3 in your calculator. And that should come out with the 336 that we just got. Okay, to illustrate why this just happened, because it comes from factorials, okay, so this is the formula for permutation. You do need to know this. I know you can calculate it, but again, on the diploma they gave you, okay, this last fall, they gave you one of these to solve for n, and you had to use the formula to solve. Okay, that's where they go with this. Okay, so be prepared for that. But my point is that don't just think I can just calculate everything. If you don't know n, you have to be able to walk it down and cancel it. We just worked on just 10 minutes ago. Okay, but see what happens here, what I'm talking about, see how this walks down? Those canceled, you're left with this. That's where it comes from. So if you see, the formula does help you with that fundamental counting principle, so that they are kind of overlapped. So maybe you're really good at fundamental counting principle, but you don't like permutations, you could probably get by without having to just use 8PR. Okay? All right, so then we did this already. You guys already did that. Okay, defining this. Okay, so 0 factorial. Okay, 0 factorial is the value of 1, not 0. Okay, it's the value of 1, not 0. Because, so for this to be equal to n factorial, the value of 0 factorial must be 1. So it's just the idea that, see if you put n minus n here, you get 0 factorial over n factorial. 0 factorial, that is a value because 6p6, okay, 6p6, like put a 6p6 in your calculator. What is 6p6? Yeah, it's 720, right? And so that means, see how this right here? If it's 6p6, that's undefined. You got a value for that. So my point is since it's 6p6, that kind of illustrates that this has to be 1. It can't be 0 because we can't divide by 0. Okay? And so it's the idea of 0 factorial is 1. Okay, just so that that works out. Okay. All right. Got a couple more examples here, and then we'll be done here. All right. In a region, vehicle license plates consist of 2 different letters followed by 4 different digits. If letters I, O, Y, and Z are not used, determine how many different license plates are possible by the counting principle permutations. So let's do counting principle first. So we know we're looking at 2 letters and 4 digits. So we have 6 spaces. Okay. So my 2 letters are, they can't be, oh, the letters are not used. So we have 4 letters that aren't used. So what's my number? 22. Can I repeat? Okay. Is Does it say it can't repeat, or does it? Two different letters? Okay, good. You're right. So 21. Okay. 4 different digits. So good point. Good job reading those. 4 different digits. So what do we have here? Yeah. There's your fundamental counting principle. Okay. You just multiply those. Okay. Well, how would this be in permutations? So first off, how many permutations do I have? How many things am I selecting? 6, but sorry, how many types of things? 2. So I have 2 permutations. I have a permutation for letters. I have a permutation for numbers. See how these are multiplied right here? This is my permutation for letters. This is my permutation for numbers. So what you're going to do is my permutation is going to be 22, choose 2. Right? We have 22 letters. I'm going to choose 2 of them. Okay? Did I put a C there? Sorry, it's a P, not a C. Permutations. I really want to do combinations today, apparently. 22 P2. That's to get your letters. And then it's 10 P4 to get your numbers. And you multiply those, and you're going to get the same exact number for both of those when you calculate, which is 2,328,000. I'll write here in the middle. 328,800? No, 480. Okay. Oh yeah, we're at the last one here. Perfect. Any questions? Okay. All right. So if you want to start this one, if you want to whatever, but this is what they do in the diploma. This is you expect to see this on some of your assessments. You can expect this to be. I've seen on 2 out of the 3 diplomas so far. I've seen them make you do this. Okay, because it makes you do a lot of algebra to solve. Okay. So we don't know what n is, but we know what the permutation formula is. So we're going to use that to our advantage. Okay. So we set the permutation formula, which would be n minus 1, this guy factorial, over what? What's the bottom? Correct. N minus 1 minus 2 factorial, right? That's what the formula says. It's n fact. What's that? It's right here. So the formula for permutation. The formula for permutation is this. That's the formula that's right there on the previous page. So why is n minus 1? Because that's n. This is n. This is r. Does that make sense? And so it looks messy on the bottom. We're just going to simplify it. So it's going to be n minus 1. We'll do the 90 in a second. And see now we're the game that we just did our notes on. We want to walk it down to cancel them. You don't want 2 factorials. So what's bigger, n minus 1 or n minus 3? N minus 1. So we're going to walk the top down. Like that. And see now the n minus 3 is no longer a problem. That's gone. And n minus 1 times n minus 2 is 90, and we solve from there. I'll stop here so we take some questions before I get going. Okay, that's where we're at. Comfortable. Okay, so we got n squared minus 3n plus 2 equals 90. N squared minus 3n minus 88 equals 0. And that factors to 11 and 8. N minus 11, n plus 8 equals 0. So that means this is negative 8. We know we're to reject negative 8 because n has to be a whole number. So n equals 11 is your solution. So 11. Okay. You could check that real quick to make sure you're right. If n is 11, well, what's 11 minus 1? 10. So in your calculator, 10 P2 should equal 90. You can check that if you'd like. Okay? All right, cool. Well, that's it for today.